In this video, let us continue our discussion on probability. First, we will look at the disjunction rule. If A and B are two events, what is the probability that either A or B occur? Let us consider the example of dice roll. What would be the probability of rolling either a 2 or a 6? There are two outcomes that corresponds to this event. Hence, the probability is 2 by 6 or 1 by 3. Now, let us compute this by adding the probabilities of individual outcomes. Probability of 2 or 6 is equal to probability of 2 plus probability of 6. The probability of getting 2 is 1 by 6 and the probability of getting 6 is also 1 by 6. This is equal to 1 by 6 plus 1 by 6 is equal to 2 by 6 is equal to 1 by 3. This is the same as the result that we got earlier. Hence, we can state the rule as probability of A or B is equal to probability of A plus probability of B. This is the restricted distinction rule because the formula works correctly only if the events A and B are mutually exclusive events, meaning that they can't both occur at the same time. In our example, getting 2 and getting 6 are mutually exclusive as the events cannot happen simultaneously. Let us represent the disjunction rule using a Venn diagram. The rectangle area represents a sample space. We call it omega. The green area represents the probability of A and the orange area represents the probability of B. If A and B are mutually exclusive, it means that the areas of A and B do not overlap. So, the probability of A or B is the sum of the areas of A and B. Let us take another example. What is the probability of drawing a card that is either a king or a spade? Let us start with the first part. What is the probability of drawing a king? There are 4 kings in the deck of cards. Hence, the probability of drawing a king is 4 by 52. Now, what is the probability of drawing a spade? There are 13 spades, hence the probability of drawing a spade is 13 by 52. Now, if we just add up the probabilities to get the probability of drawing a king or a spade, the answer would be 17 by 52. Now, let us count the cards and compute the answer. There are 13 spades and 4 kings, but one card belongs to both king and spade. Hence, the number of outcomes for this event is 16. Hence, the probability of drawing a king or a spade is 16 by 52. That means the answer that we got using the formula is wrong. This is because we have double counted one card, that is the king of spades. Let us represent the situation graphically. In the Venn diagram, the area representing the probability of drawing king and spade overlap since the two events are not mutually exclusive. The overlap area represents the probability of drawing the card that is both king and spade. Let us name this area as K and S. If we simply add the areas of K and S, the overlapped region will be counted twice. To get the correct answer, you need to subtract the area of overlap region from the sum of the two separate areas. The algebraic expression for this is the probability of king or spade is equal to the probability of king plus the probability of spade minus the probability of king and spade. This is equal to 4 by 52 plus 13 by 52 minus 1 by 52, and we got the correct answer, which is 16 by 52 rather than 17 by 52. Here is the general distinction rule in terms of arbitrary events A and B. Probability of A or B is equal to the probability of A plus probability of B minus probability of A and B. Next, we will look at the conjunction rule. Let us consider the example of coin toss. If we toss two coins at the same time, what is the probability that both coins will land heads? If one coin is tossed, the sample space is just head and tail. The probability of getting a head in tossing a single coin is 1 by 2. Let us consider the case of two coin toss. The sample space include both are head, first one head and the second tail, first tail and the second head, and both are tail. Hence, the probability of getting two heads is 1 by 4. Let us compute this by multiplying the probability of two independent events. Probability of head and head is equal to probability of head into probability of head. This is equal to 1 by 2 into 1 by 2 is equal to 1 by 4, which is the same as we have computed earlier. This is the restricted conjunction rule. If A and B are independent events, probability of A and B equal to probability of A into probability of B. However, if the events are not independent, then we need to use a modified version of this rule. Let us consider dice roll once again. What is the probability that the dice roll is both even and prime? Let us call E the event that the dice roll is an even number, and let us call P the event that the dice roll is a prime number. The outcomes corresponding to the event E is 2, 4 and 6. Hence, the probability of dice roll is even is 3 by 6 or 1 by 2. The outcomes corresponding to the event P is 1, 2, 3 and 5. Hence, the probability of dice roll is prime is 4 by 6 or 2 by 3. What we need to compute is that the dice roll is both even and prime. Let us try with the restricted conjunction rule. Probability of E and P is equal to probability of E into probability of P. This is equal to 1 by 2 2 into 2 by 3 is equal to 2 by 6 or 1 by 3. But we know that there is only one outcome that corresponds to the event both even and prime. Hence, the actual probability of getting even and prime is 1 by 6. Hence, the answer we got by applying the formula is wrong. The formula doesn't work because the events E and P are not independent. Hence, we need to modify the formula. The general conjunction rule is probability of A and B equal to probability of A into probability of B given A. Let us compute the probability of P and E using the modified formula. Probability of E and P is equal to probability of E into probability of P given E. This is equal to 1 by 2 into 1 by 3. The probability that a roll is prime, given that it is even, is 1 by 3. Since among the even numbers 2, 4 and 6, only 2 is prime. So the probability is 1 by 2 times 1 by 3 is 1 by 6 and we get the correct answer. Let us compute the probability using the other way. Probability of P into probability of E given P. That is the probability of roll being even given that it is prime. This is equal to 2 by 3 into 1 by 4. Since out of these 4 primes only 1 is even and we got the answer 1 by 6. So to sum up, this is the general conjunction rule. Probability of A and B equal to probability of A into probability of B given A, or probability of A and B equal to probability of B into probability of A given B. Both formula will give you the same answers.